Well done. Thank you, Archie. Have a seat there. And at the end, big round of applause for Archie. Actually takes quite a lot of effort to press the cloud in. At the end of the show, come and I'll give you a little bit of this, and you'll see how it has bubbles. It's as easy as that to make bubbles. It's a little bit scary, though. Do you know where the carbon dioxide comes from? I learned this when I studied geology. This might be a bit of a hint. Where does the carbon dioxide that we drink in our fizzy drinks come from? Yes. The ground, because that's where rocks, yeah. A really special place underground? Any more? When you push under the bottom, you're keeping pressure there. The dry ice actually comes from processing petrol. So, probably not the healthiest thing. It's delicious though. I mean, it's not that bad if you drink a little bit, but certainly not the kind of thing that you'd like to drink a lot of. It's also acidic. So if you drink sparkling drinks, what do they put into the drink for it to balance the acidity? A lot of sugar. Though now they put things that are not sugary or not sugar into the drink, but I think the whole lot is just not healthy at all. And yet we love it. Good to know the science of it, because it prevents me from drinking too much of it. It's kind of scary to think about where it comes from, even though it's so common and we have it so often. So there's the dry ice. Let's move on to the liquid nitrogen. I'm going to show you a couple of things with the liquid nitrogen, and then we'll have the bigger explosion of the volcano there. So dry ice is at 80 degrees, almost 80 degrees below zero. Liquid nitrogen is much, much colder. I was explaining before how dangerous it can be, just like boiling water in your home. I've got here a couple of bowls, just like you would in your kitchen. And just like you would in your kitchen, you could put some water in a bowl to cook with. I'm going to put some liquid nitrogen in this one. And you'll see how cold it is. It's so cold, just like with the dry ice. As soon as the air, and remember to stay where you are. You cannot come any closer than the first row there. So if you're in the first row, good. If you want to come closer, somewhere where the first row is, but no closer than that. Just because what I have here is really, really cold. So if it spills on you, you could burn. That's why I'm wearing all this safety gear. Though I did say that all that I'm doing here is not as dangerous as what you do in your kitchen. So if you have a bowl of boiling water in your kitchen, that is dangerous. You could not do this in your kitchen with the boiling water. That's boiling. If I pour it on my hand, I'm not going to burn. If I did this with boiling water, what would have happened with my hand? I would be going to the hospital right now. Really dangerous. So you have to be very careful with dry ice and liquid nitrogen, because the difference in temperature is so big. You could pour liquid nitrogen in your hand and it doesn't burn. If I dip my hand into the liquid nitrogen, then yes, that's a problem. I'm not going to do that. That's very dangerous. So I'm going to dip other things. But as you can see, I'm wearing the glasses and the gloves just to prevent me from burning when I dip my hands into the liquid nitrogen. Because, oh, here I have a balloon. It is 200 degrees below zero. So when you dip things into the liquid nitrogen, some amazing things can happen. I'm going to do it with this balloon. That's just the balloon I blew before. That is 200 degrees below zero. What's going to happen to the balloon as soon as it touches the liquid nitrogen? That's your hypothesis. A lot of you think it might pop. If you think it might pop, you should cover your ears. Ready, steady, go! Go! Go, go. It's not popping. Science is unpredictable. Sometimes you think something is going to happen and nothing happens. There we go. We see just the balloon is floating in the liquid nitrogen and nothing is happening. Nothing is happening? Is nothing happening? Something is happening. What's happening to the air in the balloon? It's going out. No, look, the knot is still there. The air is inside the balloon. It's not going anywhere. It's just getting colder. The air is shrinking. Exactly right. That's what's happening. When air gets really cold, the air shrinks. So in this balloon, we've got air that is shrinking. And it's shrinking up to the point where some of it will be liquid, like liquid water. So this balloon is full of liquid air. This is weird, look. It takes a lot less space because it's shrunk. Just like water though, when you boil water, what happens to the water when it boils? What does it turn to? It turns to vapor. So I've got here a balloon full of liquid air. I'm going to put this here. And if we boil the air in the balloon, it will turn to vapor again. We can blow into it. Can you blow? Blow there and see the air is turning to gas again. And the balloon made it. Wow, it's totally frozen there. Look. The balloon made it back to the earth. Oh, there's a little bit of ice in it. That must have been some water that froze in the air. Amazing. Now this is a balloon full of air. If I grab a balloon that has no air, just a balloon here, oopsie daisy. Alrighty. Phew. Balloon full of nothing. There we go. I'm going to put this in the bucket, in the bowl. What do you think is going to happen to this balloon? Ugh. Oh, it's going to blow up. You think the liquid nitrogen might turn into gas in it? Remember, whatever I put in the liquid nitrogen freezes. So this balloon is frozen. You saw how elastic it was? Look, I'm going to grab it. There's the balloon. Look. So it cracks really easily. This happens to rubber. Not even at 200 degrees below zero. In Antarctica, rubber would crack like this. So I'm definitely not going to put my hands in there. But, let me grab this. I'm going to put the liquid nitrogen in that volcano. I'm going to show you what's going to happen. Look, I've got here the bottle. I'm going to pour some liquid nitrogen into the bottle. And, well, when the liquid nitrogen is inside the bottle, it'll start turning into gas, just like it did in the balloon. And gas takes a lot more space. So this bottle has liquid nitrogen. I might put another balloon here, look. Just so that you see what's happening in this bottle. I'll put a bit more liquid nitrogen. Liquid nitrogen in the bottle. We're preparing the bottle for the big explosion now. The liquid nitrogen in the bottle. There you go. It's turning to gas. If I put a balloon over the bottle, there we go. See, the balloon is filling up with air. Pure nitrogen, which is in the bottle, and it's turning to gas, so it takes more and more space. Eventually, this balloon is going to go so big that it's going to pop. And just like with volcanoes, we don't know when it's going to pop. We know it's going to pop, so if you want, cover your ears because it'll be really loud. Oh my gosh. Actually, this is really big. So, this balloon is going to really make a loud noise in front of my face. Oh, it's going to be very loud. Wow. And there we go. Oh wow. Look what happened to the balloon. When a balloon turns to spaghetti, it means the balloon has crossed the speed of sound. Have a seat there, have a seat. So, really loud balloon explosion. I'm going to do the same thing, but instead of using the balloon, what's going to blow up now is the actual bottle. I'm going to put the cap in, and the bottle is going to go boom. Really big explosion. It is not going to be very loud though, because I'm going to put it inside the volcano, which has a lot of water. So when the water blows, or when the bottle blows, the water is going to erupt. That's going to be like a volcano. We did this in the morning. Some of you were here in the morning. So if you remember the volcano this morning, it went really, really high. I got completely soaked in water. And actually the first row here got completely soaked in water as well. If you don't want to get soaked in water, move back. If you want to get soaked in water, come and sit down around here. And if you have a cell phone with slow motion, prepare your cell phone, because what you're about to see is amazing. And in slow motion, it'll be even more amazing. So this volcano is going to grow, and just a warning for everyone standing in that side of the road. The road is tilted on that direction. So what happened this morning is the actual barrel jumped and fell in that direction. So there was quite a big group of people that were soaked in water right there. If you don't want to be soaked in water, move to the safe area here. On the other hand, actually, that is a very good place to take an amazing video of the whole street full of people and the volcano going. So I'm gonna set this up. I need to move this sticker away, and then we will see a big eruption. Let's do it. 10 years ago, the leader was a volcano that we had active lava flows all around here. We are in it. The crater of the leading volcano will be way higher, and it's just being eroded by the rain and so on. And we are actually inside a volcano. When you go around the rim of the rock, you see, from inside a volcano. 10 million years after, we are going to see the eruption of another volcano here. So, they came out. And this, for those of you that saw this morning, let's see which one is bigger. This is a Sprite bottle. This morning we did it with a Coke bottle. And a Coke bottle, this morning was about the biggest one I've ever seen. It was way higher than this building. So, if you have a cell phone and you're recording this, make sure the volcano is at the very bottom of your picture. You don't want any road. You just want this. And then a whole lot of space, because the water is going to go really, really high. So the volcano is at the bottom of your frame, and a lot of space for the lava to shoot up in slow motion if you have slow motion. Let's see how high Sprite goes. Hands up if you think Sprite is going to go higher than Coke. I'll tell you, if you were this morning, you can compare yourself. Hands up if you think Coke is stronger than Sprite. Hands up if you think it's about the same. For me, let's see, we're doing science here. Coke was amazing. Mountain Dew shall be my next eruption. Alright, so more liquid nitrogen into the bottle, and then the eruption. Let's do it. Are we ready? And straight after the eruption, I will pass on the mic to Jonathan for another magic show. We are doing magic and science all through the day here. There we go. The more liquid nitrogen I put, the faster it will happen. So it's always a bit of an unknown how much to wait. This morning we waited about 30 seconds or so. Let's see, there we go, that's enough. So we've got the liquid nitrogen in there. I'm going to take this away. And in my next show, by the way, in another hour, I'll have another show. Instead of a volcano, I'm going to do a big summer storm. So big cloud coming up. But for this show, let's end with a big volcanic eruption. For those of you that might have just arrived, it is very likely that 200 years of water are going in that direction right now. So you might get wet. If you don't want to get wet, make yourself come through and come to this area there, because that's the safe spot. Yeah. Alright, let's do it. As soon as I put the cap on, it's going to happen anyway, anytime. Do not move, especially here in the first row. Stay where you are. I'll show you the bottle at the end. That's it. Anytime now it's going to happen. We just have to wait and maybe it goes up with the music. Let's see. The more we wait,